Hello students, in today's class we are going to study the very basics of spectroscopy. So let's have a look how we can define it. Spectroscopy is the branch of science which involves the interaction between matter and electromagnetic radiation. And it is this interaction which forms a very important part in this field of science. And when we will study about the spectroscopic techniques in detail, generally it's defined as the interaction between electromagnetic radiation and the sample. So the word sample is used most of the time rather than matter. Electromagnetic radiation. So these radiations have electric field from this word electro and magnetic field oscillating perpendicular to each other and to the direction of propagation. So we can have a look at how these radiations look like by looking at the graph shown here on the right hand side, where this y-axis represents the electric field. This z-axis is representing the magnetic field, moreover shown by the blue colored waves, and the electric field shown by the red colored waves. So we can see that they are oscillating perpendicularly to each other and to the direction of propagation, which is represented here with this x-axis. Also, these electromagnetic radiations are dual in nature. Dual means these radiations can behave like waves, and these can also behave like particles. These radiations do not require any medium or molecules to propagate. Further, the shorter waves will carry more energy than the longer ones. The energy of electromagnetic radiations is given by the expression E is equal to h nu, where E is representing the energy of electromagnetic radiations, h is the Planck's constant, and nu is the frequency of the radiations. So when we say that shorter waves, it means that their wavelength is smaller, or we can say the difference between two crests is small. And when we say longer waves, it means the wavelength is longer, or we can say that the distance between two crests is higher. Electromagnetic spectrum. So in this spectrum, as you can see here on the top, we have written the entire range of electromagnetic radiations. So gamma rays, X-rays, ultraviolet radiations, visible radiations, infrared radiations, microwave radiations, radio waves. These all form a part of electromagnetic spectrum. But why it is called spectrum? Because these entire range of electromagnetic radiations are arranged in a particular order. So as you can see, when I am moving towards right, it's written we are moving from shorter to the longer wavelength. Means moving towards right, the wavelength is increased, or I can say when we move towards left, the frequency is getting increased. So this pattern of arranging the electromagnetic radiations in increasing order of wavelength or the decreasing order of frequency constitutes the electromagnetic spectrum. Also, as we have discussed in previous slide, that energy of electromagnetic radiation is given by the expression E is equal to h nu. From here, I can say that the energy is directly proportional to frequency. Directly proportional means when the frequency will increase, the energy will increase. So that's why we have written this thing here: higher frequency, higher energy. Or simultaneously, I can also say when the frequency will decrease, the energy will decrease. This expression can also be rewritten like this, where we will write frequency by C by lambda. Or from here, we can say that the energy is inversely proportional to lambda. Lambda is how we represent the wavelength. So when lambda will increase, it means energy will decrease because they are inversely proportional to each other. This is what we can see here on the right hand side: longer wavelength, lower energy, or if we say shorter wavelength, it means higher energy. So on this behavior, we have arranged the electromagnetic radiations. So let's see how these electromagnetic radiations, which are there in the electromagnetic spectrum, can be visualized in our daily tasks. So first of all, we have the radio waves. So being longer in wavelength, they are generally used for radio stations. Microwaves, they are used for cooking snacks, as we have already got the microwaves at home, which we are used for cooking purposes. We have the infrared radiations, which makes up heat. Visible light, more familiar ones, and we have heard them a lot. It means they can be seen with the eye. It's only this part of the spectrum which is visible with the eye. And this constitutes all colors of the rainbow. Ultraviolet, also known as UV rays, these are harmful for human body because they are responsible for sunburns. Next, we have got the X-rays. So these are higher in energy. So being higher in energy, they have the tendency to penetrate within the body. And because of that, it's possible to take the pictures of our bones. Gamma rays, being highest in energy, they are most of the times used in nuclear physics for the manufacture of nuclear bombs. So that's why it's written. It's the part of many superhero origin stories like the Incredible Hulk. So here comes the important part. What happens on interaction between electromagnetic radiation and matter? So matter is, it can be an atom, it can be a molecule, it can be a compound. And when we talk about compound, it can be an inorganic compound, it can be an organic compound. We will be studying about all this in your higher classes. Firstly, atoms or molecules can absorb or emit electromagnetic radiations of specific energy when interaction takes place. So this word absorb and emit is very important here. So let's have a look at absorption first. So before moving towards that, let me tell you about these two energy levels, which I have written as EGS and EES. So EGS stands for energy of the ground state and EES stands for the energy of excited state. So being at the ground level and being at the lower level, we say this energy level is lower in energy, or sometimes also called as lower energy level. So EES being on the top or on the higher position, we say this is higher energy level. So we have got a particle, which can be an atom or molecule, which have got the electrons associated with it. So when it is made to interact with the electromagnetic radiations, whose energy is h nu, so when it will absorb those radiations, what will happen? Its energy will increase. so that particle can no longer stay in this ground state energy level. So it will jump to the higher energy level, or we can say the excited state energy level. And as you can see, I have shown the difference in energy between the ground state and excited state by delta E. So moving towards emission. Emission happens when the particle was there in the excited state or in the higher energy level. So being unstable in the higher energy level, it will try to come back to the ground state or the lower energy level. So in that process, what will happen? It will try to emit the radiations whose energy is given by hν. So as it is emitting the radiations, so that's why it's known as emission. So sometimes we also can notice that we have the absorption spectroscopies, we have the emission spectroscopies, but particularly most of these spectroscopies make use of absorption phenomena. And the important part which we should take care of when this interaction is taking place is that the energy of absorbed or emitted electromagnetic radiation, it should be equal to the difference in energy levels between the excited state and ground state. Otherwise, the absorption will not be able to take place. So I can also say that delta E should be equal to hν. This is the very important criteria for absorption to occur. Secondly, atoms or molecules undergo a change when they will made to interact with electromagnetic radiations. So what type of change can take place? So as you can see here, we have got the translational energy. It means on interaction, the molecule can either translate to and fro, or because it has got the rotational energy within itself, it can start rotating, or it can start the vibrations, or it can show the electronic level transitions. So what type of change the particle will undergo, that depends upon what type of electromagnetic radiation it's absorbing during the interaction. So different parts of electromagnetic spectrum affects atoms or molecules in different ways, because different types of electromagnetic radiations have different types of energies associated with them. So that's why it will be affecting the particles in the different ways. So if we see right here on the left hand side, we have the radio waves. So when these type of electromagnetic radiations are made to interact with the sample, they will cause nuclear energy level transitions. When microwave radiations are made to interact with the sample, they will cause molecular rotations. When infrared radiations are made to interact with the sample, they will cause molecular vibrations. Visible light and ultraviolet radiations will cause electronic transitions, or rather I can say here that they can cause the valence shell electronic transitions. X-rays, being higher in energy, they are even able to eject the inner core electrons, which are tightly held by the nucleus. So they can cause core electron transitions, or sometimes we can say inner shell electronic transitions will take place. Gamma rays, being highest in energy, they are mostly used in nuclear physics, so we are not going to talk more about them here. So let's have a look at how these different types of electromagnetic radiations are getting involved in different spectroscopic techniques. So first spectroscopy, We have the nuclear magnetic resonance, which is also known as NMR spectroscopy. It makes use of radio waves. Second spectroscopy technique, which we can talk here, is microwave spectroscopy, which make use of microwave radiations. Infrared spectroscopy makes use of infrared radiations. Ultraviolet or UV spectroscopy makes use of ultraviolet radiations. X-ray spectroscopy makes use of X-rays. Gamma ray spectroscopy makes use of gamma rays. So you must have noticed that all these different spectroscopic techniques are somehow named after the electromagnetic radiation which is getting involved or which is made to interact with the sample. So let's recapitulate about all these spectroscopy techniques which we have discussed in the previous slide. So first we have nuclear magnetic resonance spectroscopy. And in this branch of spectroscopy, radio waves are used. And when these radio waves are made to interact with the sample, the nuclear spin states are involved. Or I can say that nucleus will flip. They will turn upside down. We will be discussing all these in detail in our coming classes. Infrared spectroscopy involves the interaction of infrared radiations with the sample. And when they will interact, we know that a change takes place within that particle. And here, vibrations will be noticed within the bonds. And the bonds can bend or stretch depending upon the amount of energy of IR radiations which are absorbed. Next, we have colorimetry, ultraviolet visible spectroscopy, and atomic absorption spectroscopy. So these three involve the use of visible and UV radiations, and when they are made to interact with the sample, they will cause valence shell electronic transitions. So as it's written here, the electrons will jump to higher energy level. So this jump or this movement is known as a transition. Uses of spectroscopy. Firstly, it can be used to determine the molecular masses or the molecular formulas of the compound which are present within the sample. Secondly, they can be used to identify what type of bonds are present, like whether it's carbon-hydrogen bond, whether it is oxygen-hydrogen bond, and we can identify the functional groups. For example, whether it's carboxylic functional group, is it alcoholic, is it an aldehyde, is it a ketone? So we can detect all these by using spectroscopy techniques. Thirdly, we can identify the structure of the compound which is present in the given sample. Fourthly, it helps us in carrying out the qualitative analysis. Advantages of spectroscopy. First of all, the sample is required in very small quantity. Secondly, it's quite time efficient because it takes very smaller time for the sample analysis. Thirdly, it's cost effective in long run. Fourthly, it's highly reliable technique. And last, it gave us the permanent records in the form of graphs. So let's revise what we have discussed till now. Spectroscopy uses light and other radiation of electromagnetic spectrum which is made to interact with the sample. And sample can be in any form. It can be solid, it can be liquid, it can be gas. So you can understand that I am laying most of my focus on this word, interaction. Second, the interaction depends upon the energy of electromagnetic radiations. Different types of spectroscopy uses different type of electromagnetic radiation. For example, we said that NMR spectroscopy makes use of radio waves. Different parts of electromagnetic spectrum affects atoms or molecules in different ways. For example, we said that molecular rotations can take place, molecular vibrations can happen. So these all type of changes we can notice when the interaction will be taking place. So let's brainstorm. Let's see how much you have learned till now. First, what kind of energy level transition is caused by the absorption of infrared and ultraviolet radiations? Second, what parts of electromagnetic spectrum does radiation with the falling frequency belongs to? I hope you all will be able to solve these questions by yourself. If you need help, you can either go back, you can check the previous slides, and if you still feel any kind of difficulty, you can click on the link given below. Thank you.